Imagine a modern battlefield for a second. You've got a multi-million-dollar military base. It's heavily fortified, guarded by state-of-the-art radar, and packed with highly advanced surface-to-air missile systems. Now, imagine a swarm of cheap, off-the-shelf, commercially available drones, costing maybe $500 or around 40,000 rupees each, swarming that exact base. If you fire your incredibly expensive missiles to shoot down every single one of those cheap drones, you aren't just exhausting your physical ammunition. You are quite literally bankrupting your own military in the process. It's wild, right? But this is the asymmetrical warfare dilemma of the modern age. How do you defend against a low-cost, high-volume threat without bleeding your entire defense budget dry? So let's break down the math, because the economic contrast here is just mind-boggling. A traditional kinetic interceptor, like a standard surface-to-air missile, can cost anywhere from 3 to 10 crore rupees for a single shot. On the other side of the equation, a directed energy weapon. Firing this weapon costs between 200 and 300 rupees. I mean, we are literally talking about the price of a cup of coffee or a few liters of petrol to completely neutralize an incoming aerial threat. This isn't just a minor cost savings measure. It's an absolute paradigm shift in the economics of warfare. So, welcome to today's Explainer, where we are unpacking a technological marvel that is fundamentally rewriting the rules of aerial defense. We're talking about Sahastra Shakti, a name that beautifully translates to 1,000 powers. This is India's indigenous, high-powered directed energy weapon. It's clean, it's incredibly cost-effective, and it operates completely silently. It is, for sure, a true silent killer of the skies. All right, here is our roadmap for today. We'll start with the asymmetric drone problem, then enter the world of Sahastra Shakti Mk-II. After that, we'll cover the anatomy of a silent killer, trace the journey from inception to indigenous innovation, and finally wrap up with Project Surya and DRDO. Before we really get into the weeds here, I want to give you some quick context. Driven by shifting geopolitical pressures and a rapidly modernizing tactical landscape, the years 2025 and 2026 are turning out to be an absolute era of breakthroughs for Indian defense technology. Sahastra Shakti is just one of several major leaps happening right now. We're actually going to cover the full, comprehensive list of these breakthroughs in a separate explainer. But for today, we are giving Sahastra Shakti the dedicated spotlight it absolutely deserves. Okay, kicking things off with Section 1, the asymmetric drone problem. To understand why this is such a big deal, we have to look at why traditional air defense is suddenly struggling. According to the Journal of the United Service Institution of India, an adversary can deploy a simple quadcopter drone for surveillance or even to drop an improvised explosive device for as little as 40,000 rupees. As we touched on earlier, intercepting that with a conventional missile is a financial disaster. And this is especially crucial for the success of Indian Defense Forces right now. Along borders like Punjab, Rajasthan, and Jammu, forces face a relentless, high-frequency threat of these low-cost incursions. They're constantly being used for smuggling weapons, narcotics, or just electronic disruption. Traditional defenses are logistically unsustainable here. You simply cannot shoot a 10-core missile at a drone that costs less than a smartphone. The math just doesn't work. Which brings us to the solution in Section 2. Enter Sahastra Shakti Mk-II. On April 13, 2025, at the National Open Air Range in Kurnool, an unassuming vehicle-mounted high-power laser quietly changed the game. When this weapon fires, there's no deafening roar, right? There's no smoke trailing behind a missile. There's no massive explosion. It is just precision light, completely invisible to the naked eye, doing exactly what tons of metal and high explosives used to do. So what actually is a directed energy weapon, or a DEW? Well, unlike a gun or a missile launcher that fires a physical projectile, a DEW fires focused electromagnetic energy. Because it's literally light, it travels at the speed of light, which is around 300,000 kilometers per second. There is zero delay from the moment of detection to the moment of impact. It's instantaneous. Because it travels that insanely fast, evasive maneuvers by a targeted drone are mathematically impossible. If the laser is on you, you are already hit. No way around it. Let's dive a little deeper in Section 3, Anatomy of a Silent Killer. Let's look under the hood at the technical specs. The Mk-II boasts a 30 kilowatt power output, and they achieve this by cleverly combining 6 5-kilowatt fiber lasers into one highly concentrated beam. To put that into perspective, that's enough concentrated energy to power a small neighborhood focused into a beam roughly the width of a single coin. It has an effective range of up to 5 kilometers and uses a 360-degree electro-optical and infrared sensor system to hunt its targets. But perhaps the most staggering metric here, it boasts a lock-to-kill time of under 1 second. And because it uses thermal kill mechanisms, literally melting or blinding the target, there is zero collateral blast damage. That is absolutely vital if you're defending areas right near civilian settlements. So how does this actually play out in the field? The system basically operates as a deadly duo across two 4x4 vehicles. First, the command and control vehicle tracks the incoming drone swarm using those highly sensitive sensors we just talked about. It then feeds that targeting data instantly to the second vehicle, the beam control unit, which fires the silent laser. The result? The laser either scrambles and completely blinds the drone's optical sensors, or it focuses intense thermal energy to physically burn a hole right through the drone's structural hull mid-air. The drone just drops out of the sky like a stone, and the base remains completely untouched. Moving on to Section 4, Inception to Indigenous Innovation. You know, this incredible technology didn't just happen overnight. The foundation didn't even start with hardware. It started with a vision. Way back in a 2012 research paper, Indian defense scientists foresaw that the future of warfare would be overwhelmingly dominated by cheap, unmanned aerial vehicles. They realized India needed an indigenous, cost-effective countermeasure long before drone swarms were making front-page news every day. This visionary program took shape under the DRDO, spearheaded by the Center for High Energy Systems and Sciences, or CES, down in Hyderabad. We saw the 2-kilowatt Mk-II successfully shoot down a drone in 2024. Then they rapidly scaled it to 12 kilowatts. And finally, that monumental April 2025 test in Kernel proved the 30-kilowatt Mk-IIA was a resounding, battle-ready success. But let's be real, getting a laser to work in a pristine, climate-controlled lab is one thing, getting it to work on a dusty, sweltering battlefield is another universe entirely. The CES engineers had to overcome some massive hurdles. They managed the extreme heat of the weapon using liquid-cooled fiber technology. They kept the beam tightly focused over 5 kilometers by developing adaptive optics, which are essentially these highly advanced smart mirrors that rapidly adjust their shape in real time to compensate for atmospheric distortion. They solved the mobile field power issue using integrated heavy-duty battery banks right in the vehicles, and remarkably, they achieved over 70% indigenization. In fact, DRDO is already transferring this technology to private sector companies for mass serial production. So what is the future of laser defense? Let's check out Section 5, Project Surya and DRDO. Sahastra Shakti is really just the beginning of an entire ecosystem of directed energy. While it secures the ground, DRDO is currently putting a massive 100-kilowatt system through a rigorous marinization process for the Indian Navy. This means engineering it to withstand highly corrosive saltwater, extreme humidity, and the violent vibrations of a warship out at sea. The system is called DRDO, and it's designed to be integrated into Visakhapatnam-class stealth destroyers to literally burn right through incoming anti-ship missiles. And then there is the absolute crown jewel, Project Surya. Expected around 2027, this is a mind-bending 300-kilowatt strategic laser with a 20-kilometer range. It is specifically designed to intercept heavy ballistic missiles and even hypersonic threats. It's an absolutely massive leap. The successful deployment of Sahastra Shakti places India in a highly exclusive club of nations alongside the US and Russia. It marks a huge foundational shift toward a true light-speed kill chain doctrine. So I want to leave you with this final thought to ponder. As we enter an era where threats are neutralized silently, cleanly, and instantaneously at a fraction of a cent per shot, if the future of warfare is fought silently at the speed of light, how will traditional militaries relying on explosive, kinetic missiles adapt to survive? Thank you so much for joining me on this explainer. Keep questioning and stay curious.